Good evening everyone. Welcome to this Unacademy CAT4MBA channel. My name is Ronak Shah and we are going to discuss the number system concept. In fact, this is the 7th session of this number system concept that we have started. So we have discussed almost all important concepts related to number system as far as CAT and other MBA entrance exams are concerned. So in this session, we are going to quickly discuss factorial, binomial and algebraic formulae. So I'm sure you have all understood the previous topics. In case if you missed those sessions, then you can quickly check the playlist and you can you can just watch those videos. Okay, before I go ahead, let me quickly tell you about myself. So my name is I have completed my MBA and also in engineering, and I have more than 12 years of training experience. And not only myself, we have the best of the educators on our channel, so you can quickly subscribe to our channel and you can also keep learning every day with our daily live sessions. And this is the agenda for today. So we are going to discuss factorial, then we'll look at the power of a prime number in a factorial number. We'll look at the method how to find out the power of this prime number. Then we'll look at concepts related to number of zeros, then binomial theorem, algebraic formula, and we'll practice plenty of questions. So once again, this is our channel and this is our Telegram channel. And yes, in case if you are planning to go for subscription, do not forget to use my referral code, which is SHAH10. Okay, so you'll get that 10% discount and you'll also be able to follow my classes over there as well. So right, we are talking about factorial numbers. Before that, let me quickly see who all are present for our session today. Right, so we have a few students. Great. Okay. Yes. So yes, guys, I can see that all of you are there. Quickly show me a thumbs up. Right, quickly show me a thumbs up if you can hear me. Fine. So factorial number, I mean, you just need to, you must have seen this earlier. In case if you're not aware, let me quickly tell you that n factorial is nothing but n into n minus 1 into n minus 2 and so on and so forth up to 1. So you need to reduce the number one by one and you need to multiply all those numbers till you reach 1. Okay. So let's take example. But before that, quickly remember that 0 factorial is 1. Okay. And 1 factorial is also 1 because 1, that's it. Then 2 factorial, it's 2 into 1. Yeah. So everyone, yeah, good to see you. Hi, Arunima, Nicole, Varshini, Shubhankar, Robin, Akash. Good to see you all. Please inform other students because there was some technical issue because of which we had to restart this session. Fine. Yes. So let's go ahead. Okay, just for your information, so the next daily live session will be from 10:15 instead of 10 p.m. So as you know that from today we are starting with those LRDI sessions. So that's also very important. So please be there for that as well. Right. So 3 factorial, it's 3 into 2 into 1, right? 3 into 2 into 1. That's 3 factorial. So it will come out to be 6. This is 2 and so on and so forth, right? What is 4 factorial, guys? What is 4 factorial? So it's 4 into 3 into 2 into 1. So once again, you know 3 into 2 into 1 is 6. So if you want to find out 4 factorial, you can directly multiply this 6 with 4. So you will get 24. Same way 5 factorial. So multiply this 24 with 5. So you will get 120. Same way 6 factorial. So multiply that 120 with 6. So you will get 720. So you need to remember up to this point. Right. Okay, great. Good evening once again, all of you. Yeah, Shubhankar, what's your doubt? Quickly. Okay. So guys, this is about basics of factorial. So you should remember this thing. Okay. Now let's quickly understand the concept about how to find out power of a prime number in the given factorial. Please remember the method that I'm going to teach you will be used only to find out power of prime number in the given factorial number, right? Shubhankar, there are many faculties who will be teaching different areas. Okay, so on daily life, I mean, for example, I am taking care of number system, so other faculty will be teaching you arithmetic. Some other faculty will be teaching you geometry. Of course, I'll also cover arithmetic and geometry, but later on. So if you want to simultaneously learn multiple concepts, you can go ahead and you can definitely watch those videos. It's always useful, right? So you can even attend his session and then again when I teach the same concept, you can learn that. Okay, fine. Great. So let's quickly understand how to find out power of a prime number in the given factorial number. It's a very simple concept, guys. But before that, let me take a number 10 factorial. Okay, so what is 10 factorial? It's 10 into 9 into 8 into 7 into 6 into 5, 4, 3, 2, 1, right? Okay, I'm not going to ask you to find value of this. It's a huge number, right? But you understand what is 10 factorial. Fine. Now, if I ask you that prime number 2, how many times does it appear in 10 factorial? Or what is the maximum power of 2 in these 10 factorial? What is the total power of 2 in the 10 factorial? So can I say 2 appear once in 10? Because 10 is nothing but 2 into 5. So 2 comes 1. This prime number 2 comes 1. Okay, once. Then in 9 you will not find any 2, but 8 is nothing but 2 into 2 into 2. So there are 3 powers of 2 in 8. Guys, are you all with me? Are you able to understand this? Everyone, show me a thumbs up if you have understood this. See, we are trying to count the total power of 2 or total number of times that 2 come in the 10 factorial. So can I say in 10, 2 appears 1, okay, or 2 is used once, because 10 is nothing but 2 into 5. So 2 comes once. Same way in 8, 2 comes thrice, because 2 into 2 into 2 is 8, right? So we'll write down 3 over here. See, we are writing the number of times 2 appears in each of this number. Then again in 6, it will come once. In 4, it will come twice. In 2, it will come 1. So what is the total power of 2 in 10 factorial? So it's 1 plus 3 plus 1, that is 5 plus 2, 7 plus 1, 8. Now this was a small number. Yeah, hi Varshini. Yes, so this was a small number, so we could quickly calculate. What if I ask you to find out power of 2 in 100 factorial? Can we do it manually? No, of course not, right? It will be lots of wastage of time, right? So there is a method to find out this thing. Okay, so what is the method? Let me explain the shortcut to find out power of any prime number in the factorial number. What you need to do is you just need to divide this 10, not 10 factorial, now just take 10. You need to divide 10 first by 2 raised to 1. Okay, and you need to write down the greatest integer value, or simple words, you need to write down the quotient. So just write down the quotient here. So 10 divided by 2, what is the quotient? Quotient is 5. Then you need to divide 10 by 2 square. So what will be the quotient when we divide 10 by 2 square? 2 square is 4. So 10 divided by 4. So I can say 4 2s are 8. So quotient will be 2, right? Then you need to divide 10 by 2 cube. Okay. So what will be the quotient when you divide 10 by 8? 2 cube is 8. So 8 1s are 8. So quotient will be 1, right? Then you keep doing further. So what will be the quotient when I divide 10 by 2 raised to 4 or 2 raised to 5 and all? Can I say 2 raised to 4, 2 raised to 5 and all are more than 10? So quotient is going to be 0. So we don't need to check further. We just need to check up to this, right? So this is the power of 2 in 10 factorial. Have you understood this point, everyone? Isn't that simple? So once again, what I did is, if I want to find out power of 2 in 10 factorial or power of any prime number in the given factorial number, I need to divide that particular factorial number by different power of the prime number. So here I want to find out power of 2 in 10 factorial. So what I did is I divided 10 by 2 raised to 1, then 10 by 2 raised to 2, 10 by 2 raised to 3, and I just wrote down the quotients. That's it. And I added those quotient. So I got the total power of 2 in 10 factorial, that is 8. And we have already seen that this is nothing but total 8 powers. Yes, have you all understood this? Let's take one more example so that things become pretty clear. Suppose I want to find out power of 3 in 17 factorial. Let's take some awkward number. Suppose we want to find out power of 3 in 17 factorial. What is the power of 3 in 17 factorial? Or the other way of asking this question, what is the highest power of 3 that will divide 17 factorial completely? Both of these are one and same. I repeat, if I ask you this question, what is the highest power of 3 that will divide 17 factorial completely? That means you need to find out power of 3 in 17 factorial. Yes? Okay. So let's quickly understand how to do it once again. So we will divide this 17 by 3 raised to 1 and we will write down the quotients. So write down the quotient over here. So 17 divided by 3, 3 5s are 15. So quotient will come out to be 5, right? Then 17 divided by 3 square, correct? So 3 square is 9. So 17 divided by 9, can I say 9 1s are 9? That's how we can divide. Quotient will be 1. and 17 divided by 3 cube. 3 cube itself is more than 17. So we don't need to check further. We just need to check for this thing. So power of 3 in 17 factorial is 5 plus 1, that is 6. Yes guys, can you all find out power of a prime number in the given factorial number? Show me a thumbs up if you have understood this concept. Or if you didn't get, if you want me to take more examples, yeah, please write it in the chat box so that I'll explain you the concept with the more examples. Please, quickly. Okay, great. Fine. So let's take few more questions, everyone. So can you find out power of 2 in this 10 factorial? Acha, we have already solved this question, right? Power of 2 in 10 factorial is, of course, it's 8. So we will just write down 8 over here. Okay, the power of 2 in 10 factorial is 8. So can you quickly calculate what is the power of 2 in 23 factorial? Can you do it in your mind? Okay, so 23 divided by 2. What will be the quotient? Write down the quotients over here. 23 divided by 2. Can I say 11 is the quotient? Same way, 23 divided by 2 square. What is the quotient? So 23 divided by 4. The quotient will be 5. Right. Then 23 divided by 2 cube. What will be the quotient? So 8 2s are 16. 8 3s are 24. It will be more than that. So quotient is going to be 2. Then 23 divided by 2 raised to 4. 2 raised to 4 is 16. 16 ones are 16. So yes, the quotient will be 1. Now 2 raised to 5 is 32. So we don't need to check further. We just need to stop here. So what is the total power of 2 in 23 factorial? It will be 11 plus 5 plus 2 plus 1. So it will come out to be 19 power. Right? So power of 2 in 23 factorial is 19. Okay, so 19 power. That's your answer for this question. Not 18, it's 19. Please check your calculations quickly. It's 19, right? Great. So can we take few more questions, guys? Are you up for a few more questions? Show me a thumbs up if you want to go ahead with more questions, if you're ready for more questions. Yeah, so here it comes. Quickly find out power of 2 in 50 factorial and then 100 factorial. First calculate for 50 factorial and then calculate for 100 factorial. Now it should happen in your mind. 50 divided by 2, it's 25. Then 50 divided by 4, it's 12. 50 divided by 8. See, I'm taking different power of 2. Okay, so 50 divided by 8. 8 6 are 48, right? Then 50 divided by 16, that's 2 raised to 4. So 50 divided by 16, it's 3. 50 divided by 2 raised to 5, that is 32. So 50 divided by 32, it will be 1. And 50 divided by 2 raised to 6, so it will become 0. The quotient will be 0. So power of 2 in 50 factorial will come out to be 47. Yes or no? Everyone, please check for this. 25 plus 12, 37 plus 6, 43 plus 4, 47. Right? So power of 2 in 50 factorial is 47. Or you can say the highest 2 raised to 47 will completely divide 50 factorial. Everyone. Yes? Please remember this thing. Okay, same way, check for 100 factorial. Now let me tell you, don't apply any shortcuts over here that in 50 factorial it's 47, so in 100 factorial it will be 94. No, that won't work here. Please remember this thing. Okay, so it will not be 94 in 100 factorial. We'll have to check it manually. So once again, 100 divided by 2, it's going to be 50. 100 divided by 4, so it's going to be 25. Then 100 divided by 8, so 12 8s are 96. Right, so it will be 12. The quotient will be 12. When I divide 100 by 8, the quotient is 12. Then 100 divided by 16, so 16 6 are 96, so quotient is 6. Then 100 divided by 32, so 32 3s are 96, so quotient is 3. 100 divided by 64, quotient will be 1. Yes, and 100 divided by 128, so again quotient will become 0. So we don't need to check after that. Okay, we need to check up to 2 raised to 6. 100 factorial divide by 2 raised to 6, up to that only we need to check the quotients. So if you just add them, it will be 50 plus 25 75 plus 12 87 plus 6 93 plus 4 97. So it's going to be 97 power. Okay, in this one. Right, have you all understood this? Everyone, show me a thumbs up quickly. Yes, great. Now I can see all the answers in the answer box. Great going, guys. Okay, and yes, so we are going to solve some other questions also, guys. So whatever powers you have got for 2 in the numbers that I've just displayed, please mark it somewhere aside, because we'll require to use them in subsequent questions. So we don't need to repeat all those calculations once again. So what all questions have we seen? Power of 2 in 10 factorial, so we know it's 8. Power of 2 in 23 factorial, so it's 19. Power of 2 in 50 factorial, so it's 47. And power of 2 in 100 factorial, so it's 97. So yes, please write down somewhere so that we can use it for subsequent question. In fact, here is that question. Now please understand this question. Don't try to solve this thing, understand the concept first. You need to find out power of 4 in 10 factorial. Now the method that I have taught is used only to find out power of prime number in the given factorial number, right? So 4 is not a prime number, so we can't apply that method. You can't do it this way. Okay, 10 divided by 4, its quotient is 2, and 10 divided by 16, it's 0. So this is the power. No, this is wrong. Okay, so what we can do is we can just prime factorize 4. What is 4? So 4 is nothing but 2 square. Yes or no, everyone? 4 is 2 square. And what is the power of 2 in 10 factorial? Can I say power of 2 in 10 factorial is 8? Right, everyone? So power of 2 in 10 factorial is 8. So can I write down this 2 raised to 8 as 4 raised to 4? Yes or no? 2 raised to 8 is nothing but 4 raised to 4. So what is the highest power of 4 that will divide 10 factorial completely? It's 4. The highest power of 4 that will divide 10 factorial completely is 4. It's half the power of 2. As simple as that. Yes, guys, have you understood this concept? Same way, what is the power of 2 in 23 factorial? So it was 19. 2 raised to 19 completely divides 23 factorial, or the power of 2 in 23 factorial is 19. So can I write down this as 4? Okay, let me just write it in a step-by-step manner. 2 raised to 2 whole raised to 9 into 2 raised to 2. This is an extra power. Okay, it's of no use to us. So this is nothing but 2 raised to 2 is nothing but 4. So 4 raised to 9. So highest power of 4 in 23 factorial is this 9. The highest power of 4 in 23 factorial is 9. Yes. Have you all understood this? Can you find out power of different composite numbers in the given factorial number? First, you will have to find out power of the prime number which are used in that composite number, and then you will figure out okay, what will be power of that composite number. Correct, everyone? Yes. So if you have any doubt, please write it in the comment section in the chat box so that I can address that. Okay, fine. So let's take few more questions. Once again, 50 factorial. What is the power of 2 in 50 factorial? It was 47. So 2 raised to 47 completely divides 50 factorial. So what will be the power of 4? Now can I say directly it should be half? So what is half of 47? 47 is an odd number. So take the lower number 46. So the power of 4 will be 23. Very simple. Same way, what is the power of 2 in 100 factorial? It's 97. So what will be the power of 4 in 100 factorial? 48. Correct, because 48 2s are 96. That one extra is of no use when we want to calculate power of 4. Yes, okay. Shubhankar, yes, you have confusion. So let me just explain once again. See, once again, please understand this point. What is the power of 2? Oh, Varshini, we are going to discuss that question. By the way, see, here is that question. The question that you are asking, Varshini, it's over here, right? So we'll come back to this. I know that you were to ask me this question since I have been training for so many years. So yes, we have included all the varieties of question, right? So Jagdish, yeah, Shubhankar, for you, once again, see, first, if you want to find out power of 4 in factorial number, since 4 is not a composite number, you will have to understand that what prime number is used in 4. So 4 is made up of 2. In fact, 2 power of 2 makes 4, right? Okay, so what we'll do is first we'll find out power of 2 in this 50 factorial, which is 47, correct? So power of 4 will be half of this, right? Because 2 square is 4. So power of 4 will be half the power of 2, right? Now 47 can't be divided by 2. So take a lower number, that's 46. So what is half of 46? It's 23. So power of 4 in 50 factorial will be 23. Because this can be written in this way, 2 raised to 2 whole raised to 23 into 2 raised to 1, and 2 raised to 2 is nothing but 4, right? So what is the power of 4 in 50 factorial? It's this 23. Yes, Shubhankar, have you understood this? Is that clear now? Right, great. Okay, fine. So guys, let's take few more questions. Shubhankar, things will become pretty clear. We are going to practice at least 15 questions today related to this. Yeah, so it would become pretty clear. Now guys, quickly tell me what is power of 3 in 10 factorial and 23 factorial. Enter your answer in the comment section as x comma y. In fact, the first answer and second answer. Quickly enter in the comment section. Tell me what will be the power of 3 in 10 factorial. So you will first divide by 3. 10 divided by 3, quotient is 3. 10 divided by 3 square. 3 square is 9. So 10 divided by 9, quotient is 1. You don't need to check further because 3 cube will be 27. So this is the power of 3. Let me see how many of you have entered correctly. Right? It should be solved quickly. Right. Sudarshana, you are correct. Yes. But I think you took a little more time. It should be very quick. So what about 23 factorial? Everyone, quickly do it in your mind. See, you can't afford to write step by step in paper. Even you should not write the steps. You should do it in your mind. Okay. So 23 divided by 3, it's 7. 23 divided by 9, it's 2. 23 divided by 27, quotient is going to be 0. So no need to try, and this will come out to be 9. Right. Very fast, Akash. Very good. So yes, Robin, 10 is incorrect. It should be 9. Okay. It should be 9. Yes, Arunima, that's correct. Nicole, second is 9. Correct. So now see, you are getting that. Let's try for a few more questions. Why don't you find out power of 3 in this bigger number? Everyone, please quickly enter your answer in the chat box. Quickly do the calculation in your mind. See, you will just have to do the division up to 3 cube because 3 raised to 4 is going to be 81. So you don't need to divide this number by 81, right? So quickly type your answer in the chat box. I am doing it over here. So 50 divided by 3, it's 16. Again, see, for this, your tables should be good. If you're good at tables, you can quickly answer these questions. So 50 divided by 3, it's 16. Then 50 divided by 9. So 9 5s are 45. It's 5. Okay, 50 divided by 27. So 27 2s are 54. So we'll have to take quotient as 1. So this is the power of 3 in 50 factorial. So it will come out to be 22, guys. Silly mistakes. It's 22. Shubhankar, not 23. Correct. Same way, do it for 100 factorial quickly. What is the power of 3 in 100 factorial? So 100 divided by 3, it's 33. Then 100 divided by 9, it's 11. 100 divided by 27, it's 3. 27 3s are 81. So quotient will be 3. 100 divided by 3 raised to 4, 81. Its quotient will be 1. 81 ones are 81. And 100 divided by 3 raised to 5. 3 raised to 5 is more than 100, right? What is 3 raised to 5, by the way? Do you remember that? It's 243. Correct. So we don't need to check for that. So these are the quotients. Just add them and you will get this power as 48. Yes, everyone? Great. So all of you have now understood this, how to find out power of a prime number in the given composite number, right? So it's the time to press the like button and show me a thumbs up. Both things should happen simultaneously. Press the like button and show me a thumbs up. Everyone, quickly. So that I'll show you a few more questions, right? Okay. So here is the next question. See, once again, 5 is a prime number. Right? So now you need to find out power of 5 in 10 factorial. So we can do it with a normal method. 5, 10 divided by 5, quotient is 2, and 10 divided by 5 square. So of course it's more. So this is the power of 5 in 10 factorial. Right? Great. Okay. This is the power of 5 in 10 factorial. Okay. Same way, what is the power of 5 in 23 factorial? Everyone. So 23 divided by 5, quotient is 4. 23 divided by 5 square, 25, not divisible, quotient will be 0. So that's it. This is the power of 5 in 23 factorial. Very simple, right? Everyone? Okay, great. So now tell me what is the power of 5 in 50 factorial and 100 factorial. So quickly find out this thing and type your answer in the chat box. Please, I'm waiting. So I'm checking your answers. Power of 5 in 50 factorial. Okay. And then 100 factorial. Please write both the answers together in the chat box. Quickly, everyone. So 50 divided by 5, quotient is 10. 50 divided by 5 square, quotient will be 2. Right? Okay, so and 50 divided by 5 cube is 125, more than that, so quotient will be 0. So this is the power of 5 in 50 factorial, right? Same way, 100 factorial. See, it's very simple division. 100 divided by 5, 20. 100 divided by 5 square, 4. 100 divided by 5 cube, not divisible, so it will be 24. Right? So the correct answer is 12 and 24. It's just a coincidence that in 50 factorial we have 12 power and in 100 factorial we have 24 power. But it's not necessarily always same. It will become double. No, don't make those assumptions. Okay, we have already seen that earlier. Okay, fine. Great. So now before we move on, guys, just want to tell you once again, in case if you are new to this session and if you are unaware about our Unacademy platform, then you can quickly download our Unacademy learning app from the Play Store or App Store, and then you can attend my special sessions which are completely free of cost. You don't need to take any subscription. So I am taking special session every day at 5 o'clock on Unacademy platform as well. So you can attend my sessions over there also. I'm going to take marathon session on Sunday at 2 o'clock. So I'm going to take one marathon session on Sunday at 2 o'clock from 2 to 5. Okay, everyone. So guys, I'm just confirming this thing in case if you're not aware. 2 to 5 is the timing. Very soon it will be available on the Unacademy app under my profile. This session will be visible. Just today I'll post about that. And this is going to be complete permutation, combination and probability. Okay, in 3 hours, I'm going to teach you complete permutation, combination and probability. So it is going to be a marathon session. Okay, so please attend that. For that, you should have downloaded this app and you need to follow me. You can find me by my name, Ronak Kumar Shah. Make sure there is no space between Ronak and Kumar and then Shah. Once you type this name, then you will find an option of checking all educators. And under that you can find me in case you are not able to find me by my name. So once you follow me, you will be also able to attend the sessions. Fine. So guys, now once again coming back to this one, find the highest power of 6 in the following number. So we can't directly divide by 6 because 6 is not a prime number, it's a composite number. So what we need to understand is, do the prime factorization of 6. What is that? 2 into 3. So we need to find out power of 2 and then we need to find out power of 3. Now please check the previous data. We have already found out power of 2 in 10 factorial, so it was 8. We had already found out power of 3 in 10 factorial. What was the power of 3 in 10 factorial? So it was 4. Correct? Power of 3 in 10 factorial was 4. Yes or no? Correct. Okay, so how many pairs of 2 and 3 can I make? See, it's like this one. Now there are 8 boys and there are 4 girls. So how many couples will be can be made? Can I say there can be only 4 couples? So 6 is nothing but a pair of 2 and 3. 6 को बनाने के लिए एक लड़का चाहिए और एक लड़की चाहिए. लड़के तो हमारे पास बहुत है as usual. You know, there is always dearth of girls. So how many girls are there? Only 4. So how many couples can be made? Only 4 couples can be made. Right? Okay. So power of 6 in this 10 factorial will be just 4. Have you all understood this point? How many pairs of 2 and 3 can we make? Only 4, because we have plenty of power of 2, but we have limited power of 3. So the pairs that we can make will be equal to the power of 3, right? In fact, if you look at 23 factorial also, what is the power of 2 in 23 factorial, guys? Can you quickly tell me? It was 11 plus 5 plus 2 plus 1. This was the power of 2 in 23 factorial. So it was 19, right? And what was the power of 3 in 23 factorial? So it was 7 plus 2, right? That is 9. So power of 3 was 9, correct? Okay, so once again we have 19 boys and we have 9 girls. कितने couple बनेंगे दोस्तों? जल्दी से बताओ. 9 couple बनेंगे कि नहीं? So what is the power of power of 6 in 23 factorial, it will be 9. Yes, everyone? Right. Okay, so power of 6 in 23 factorial is 9, which is equal to power of 3. Okay, so now I'm sure by this time you would have understood that if I want to find out power of 6, now listen to me carefully. Listen to me carefully. If I want to find out power of 6, I'll have to check for the prime factorization of 6. So it is made up of 2 and 3. There is one power of 2 and there is one power of 3. Right? So in given factorial number, we will have plenty of power of 2, but we will have limited power of 3. So how many pairs will be formed? Only as much as the power of 3, right? So if I want to find out power of 6 in 50 factorial, I really don't need to look at power of 2. I'll just check what is the power of 3. I'll be able to make only that many pairs, or I'll say I'll have only that much power of 6 in 50 factorial. So what is the power of 3 in 50 factorial? Do you remember this thing? What is the power of 3? Was it 22? Guys, let's quickly do it. So it's 16 plus 5 plus 1, right? So it was 22. So power of 6 in 50 factorial will again be 22. Now we don't need to look at power of 2. Yes, everyone, have you understood this part? Okay, same way in 100 factorial. What is the power of 3 in 100 factorial? Do you remember? Let me quickly check. What is the power of 3? It was 48, right? So this is 3 raised to 48. So what will be power of 6 in 100 factorial? Of course, 48. As simple as that. Are we clear? Yes, have you all understood? Quickly tell me yes or no. Fine, great. Okay, so now let's look at one more concept, and based on this, questions have been asked in CAT exam that you need to find out number of zeros at the end of given factorial number. So let's understand this concept. Guys, let me take different numbers. Let's take a number 60, or let's take another number 400, or even if you want to take 5000, whatever number you want, you take numbers which have some zeros at the end, and let's analyze them. Let's prime factorize them so that we understand this concept in detail. Now what is 60? Prime factorize this 60. So it will be 2 raised to 4, 3 raised to 1 into 5 raised to 1. Or what is 400? So it's 2 raised to 4 into 5 square. What is 5000? So of course 1000 is 2 cube 5 cube and additional power of 5. So it will be 2 raised to 3, 5 raised to 4, and so on and so forth. Are you getting this point? Right. So what I'm trying to show you is the number of zeros at the end of any number depends on the pair of 2 and 5. I repeat, number of zeros at the end of any number. I'm not talking about factorial number here. I'm talking about in general any number, whether it's a normal number or a factorial number. It completely depends on the pair of 2 and 5 that can be made. So in 60, how many pairs of 2 and 5 can be made? Can I say only one pair of 2 and 5 can be made? And that's why there is only 1 0 at the end of 60. See, we have plenty of 2's in 60, but we have just 1 5 in 60. So how many pairs can be made for 2 and 5? We can just make one pair, and that's why there is only 1 0 at the end of 60. In fact, you can see that there are 2 zeros at the end of 400, because just check how many pairs can you make for 2 and 5 over here. So we can make 2 pair of 2 and 5, right? And that's why there are 2 zeros at the end of 400. In fact, if you check over here, we have limited 2's, but we have more 5's. So how many pairs can I make for 2 and 5? We can make only 3 pairs, right? And that's why there are 3 zeros at the end of this number. Have you understood this part? Yes or no? So if I ask you, how many zeros will be there at the end of 50 factorial? Or how many zeros will be there at the end of 10 factorial or 23 factorial and so on and so forth? So can I say there will be as many zeros at the end of this factorial number as the number of pairs of 2 and 5 that we can form, right? So let's once again quickly check how many 2's are there in 10 factorial. So power of 2 in 10 factorial is 8. How many 5's are there in 10 factorial? There are only 2 5's. So how many pairs can we make? Can I say we can make only 2 pairs? So that's why there will be just 2 zeros. Okay, if you solve this 10 factorial, it will end with 2 zeros. Same way in 23 factorial. So we have again plenty of 2. But how many 5s do we have in 23 factorial? Just 4. So number of zeros at the end of 23 factorial will be 4. Same way number of zeros at the end of 50 factorial will again depend on 5. We don't need to check for 2 now. We can just check for 5. So what is the power of 5 in 50 factorial? It's 12. So that's why that will be 12 zeros. What is the power of 5 in 100 factorial? It's 24, and that's why 100 factorial will end with 24 zeros. Yes, have you all understood? Yes or no? Quickly type in the chat box. If you are clear up to this point, type in the chat box, because we are done with factorial concept. Fine guys. Yeah. So one part is over. Now we need to discuss the binomial expansion, which is a small concept, and then algebraic formulae. Great. So we are about to complete the number system. Okay, we are about to complete the number system, guys. Fine. So now before we go ahead, there are a few more questions for you. These are some tricky questions. This will test your conceptual understanding. It's not only based on what I have taught you just now, it's based on whatever I have taught you till date. So this is the 7th session of number system, and you have been attending almost all the sessions. So let me test your understanding. Look at this first question. N factorial is divisible by 1 lakh but not by 10 lakh. Can you find value of n such that n factorial is divisible by 1 lakh but not by 10 lakh? Okay, so guys, let me explain this thing. In fact, I'll explain this question. The next question has to be solved by you. So any number, when it is divisible by 1 lakh, okay, can I say it should have 5 zeros at the end? It should have 5 zeros at the end, only then that number will be divisible by 1 lakh. Yes or no? And it is not divisible by 10 lakh. Matlab it should not have 6 or more zeros. If you take a number with 6 or 7 zeros, of course it will be divisible by 1 lakh. But here we want that number not to be divisible by 10 lakh. Matlab it should not have more than 5 zeros. It should have exactly 5 zeros. So we need to find out a factorial number which has exactly 5 zeros at the end, right? 5 zeros at the end means it should have exactly 5 power of 5, neither less nor more. Of course, power of 2 will always be plenty more than power of 5. So we just need to check for power of 5. Okay, so we understand that 20 factorial, if I take 20 factorial, what is the power of 5 in 20 factorial? Of course, it's going to be 4. Now, if I take 21 factorial also, power of 5, see, it will remain 4. 22 factorial, 23 factorial, 24 factorial, all of this will have power of 5 as 4 only. Matlab, all these numbers are going to end with only 4 zeros. Yes or no, everyone? Are you with me? Okay. Now, if I take 25 factorial, what is the power of 5 in 25 factorial? See, it will not be 5. It will be directly 6. Why? If you want, you can just divide 25 by 5. So it will come out to be 5 plus 25 divided by 5 square. So I am checking power of 5 in 25 factorial. So 25 divided by 25, again it's going to be 1. So what is the power of 5 in that? It's going to be 6. In fact, you can also think it this way, that 25 factorial is nothing but 24 factorial into 25. So the moment you bring 25 in the picture, 25 brings 2 power of 5. So suddenly power of 5 will jump by 2 here. Yes, and that's why there is no such number exists which is divisible by 1 lakh. No such factorial number exists which is divisible by 1 lakh but not by 10 lakh. Right? The reason we have just understood that we will find numbers which have 4 zeros or which will have directly 6 zeros, because we will find factorial numbers which has power of 5 as 4 or power of 5 as 6. We will not find any number which has exactly 5 power of 5. We will not find any such factorial number, by the way. Right? So I hope you have understood this concept. Have you all understood this? Show me a thumbs up quickly. And then try for this question. Try for this question. N square plus 1 is divisible by 3. So find the value of n. Now this question, the second question, is not related to factorial. It is just a general question, everyone. It's a general question. Yeah, so n square plus 1 is divisible by 3. You need to find out one value of n such that n square plus 1 is divisible by 3. Guys, take any value of n. You know, in such question you can just start by trial and error. If I take n as 1, so n square will be 1 plus 1 2, not divisible by 3. If I take n as 2, okay, so 2 square 4, 4 plus 1 5, not divisible by 3. If I take n as 3, so 3 square is 9, plus 1 kar doge, again it will not be divisible by 3. So in fact, again you will not find any such number. So no such number exists. No such number exists. No such number exists. Okay, there is no such number, you know, square of which plus 1 will be divisible by 3. Now this is something which you can understand by slightly exploring, okay, further. So now this third question, n has exactly 7 divisors. So which is that number where n has exactly 7 divisors? Now you remember that formula to find out number of divisors, everyone? Let's look at that once again. Okay, so no such number for both of this, no such number. Okay, now n has exactly 7 divisors. So guys, for any number n of the form a raised to p, b raised to q, c raised to r, and so on and so forth, right? No, Shubhankar, there are infinite numbers for this one. Okay, so you are just going by the flow. There are infinite numbers. The answer is infinite numbers. Now let me explain that why. So you understand the prime factorization. Then number of factors, divisors means nothing but factors. So number of factors of n. What is the formula for that? Power plus 1 into power plus 1 into power plus 1 and so on and so forth. So guys, if I take a number of this form, 2 raised to 6, can I say the number of factors of 2 raised to 6 will be 6 plus 1, that is 7. Number of factors, right, will be 7 for 2 raised to 6. What is 2 raised to 6? 64. So 64 has 7 factors. So one number is 64. In fact, I can take all this number now, 3 raised to 6, 5 raised to 6, 7 raised to 6 and so on and so forth. So there are infinite prime numbers. Any prime number raised to 6 power, you know, any n where there is just one prime number raised to 6 power, the number of factors will be 7 factors. It will have 7 factors. So there can be infinite numbers, right? Everyone, have you understood this? Perfect. Okay. Yep. So let's go to the next part now, binomial expansion. So guys, this is called binomial expansion, and in fact using this formula, all this algebraic formulae have come. A plus b whole square, or a plus b whole cube, or a plus b whole raised to 4 and so on and so forth. So what is this expansion? Please pay attention carefully. The first term, see, this is x, this is y, and whole raised to n. Okay, so the first term will have first variables n power. ये जो power है ना, उसको सीधा यहाँ पे रख दिया. The second term will have 1 less power of x and 1 power of y. The third term, forget about this nc2 and all these things. Okay, this is nc1. This is nc0. If you want, you can write it this way. So forget about this nc0, nc1 and so on and so forth. We are not looking at the coefficients right now. Just look at the variable. Look at the variable. So first term has x raised to n. I can say y raised to 0. Second term has x raised to n minus 1, y raised to 1. Third term has x raised to n minus 2, y raised to 2. Then x raised to n minus 3, y raised to 3. So if you observe, the power of x is reducing and the power of y is increasing. As simple as that. Can you remember this pattern? So let's apply that over here. The first term will have a square and 0 power of b. Then the second term will have 1 less power of a and 1 power of b. The third term will have 2 less power of a. That means a raised to 0, matlab no power of a, and 2 powers of b. Right? Now what about this coefficient? So first term will be nc0. So here it will be 2c0. then second term will be 2c1 and third term will be 2c2. Now if you are aware about this NCR, you know NCR is equal to n factorial upon n minus r factorial into r factorial. In case if you don't remember this, don't worry, permutation combination Sunday 2 to 5, you will understand everything. So for timing, you can just remember, okay, there is something called NC0, NC1, NC2, NC3 up to NCN. Okay, remember one thing, that NC0 and NCN both are equal to 1. Right, so this 2c0 will be 1, so the first term will be a square. 2c1 is 2, so second term will be 2ab. 2c2 is again 1, so third term will be b square. So that's how we got a square plus 2ab plus b square. Let's apply the same concept over here. So it will be first term will be a cube, then second term will be a square b raised to 1, then third term will be ab square, and fourth term will be b cube. Right, a key reduce one power, so it will disappear. And what about the coefficients? So first term will be NC0, which is 1, so we don't need to write it. The second term will be 3C1, so it's going to be 3. The third term will be 3C2, so again it's going to be 3. And the fourth term will be 3C3, so 3C3 is 1. As you know, NCN is 1, so this is going to be 1. So this is the expansion of a plus b whole cube. Have you all understood this? So same way you can expand this one as well. Now one thing that you need to remember is, if I take some expression of this form, a raised to a plus b whole raised to n, few points that you need to remember. So first term will have a raised to n and 0 power of b. Last term will have 0 power of a and n power of b. Ultimately you take any term, the sum of the powers of a and b will be equal to n. See here, what is the sum of the powers of a and b? It's 3. What is the sum of power of a and b? It's 3. So the sum of powers of two variables will be equal to n always. First point. Second, the number of terms in this expansion will always be n plus 1. These are the number of terms. Yes guys, will you remember this point? The number of terms will be 1 more than the power of n. So for example, a plus b whole square. So that is 2 over here. So how many terms are there? First term, second term and third term. 3 terms. A plus b whole cube, there is 3 power of so what are the number of terms? There are 4 terms. So in general, if there is n power, then the number of terms will be n plus 1. Are we all clear with this? Show me a thumbs up if you have understood this binomial expansion. Of course, you can revisit this video so that you can remember that once again. Okay, fine guys, so just to quickly show you some algebraic formulas. So these are the important algebraic formulae that you need to remember. And yes, you can also remember this point, that a raised to n plus b raised to n cannot be factorized when n is odd, and a raised to n minus b raised to n can be factorized for all values of n. Okay, this can be factorized for all values of n. So this is something that you need to remember. I mean, just because of time shortage, I'll have to cut it short because the next session is from 10:15. Right, okay. So guys, you can actually, after the session, you can try to solve this question, and then if required, we'll discuss in the next session. So next time our session of number system session is going to be directly on I'll just have to check. Okay, so I think there is no session tomorrow. Acha, just one more thing guys, so tomorrow we are keeping marathon session. Tomorrow Saturday we have marathon session on numbers. What is the timing? It's 1 to 5 p.m. everyone, so please block your afternoon. Tomorrow 1 to 5 p.m. marathon session. We are going to revise number system completely, all the concepts of number system. Are we clear? That's it for today guys. So our next faculty, Mr. Shyam Jagrut, will continue with logical reasoning and data interpretation. So please attend that. Practice LRDI as well. I'm sure he has some really nice technique to teach you, so you'll all be benefited. Okay, before I go ahead, so let me quickly tell you about our plus subscription. In case if you're not aware, so you will get test series, you will get leaderboard, and you will also get access to the faculty directly. You can have more personal interaction, and for that you need to download the app and then select your goal as CAT and click on the subscription. Go for 1 or 2 year plan. Use my code SHAH10 if you want to go for this, so you will be benefited, and you can also follow me. These are our other entrance exams, and yes, at least download this app in case if you haven't downloaded. So that's it from my end. The next session just